Hi, everyone. I was trying to find a marker so I could write my Twitter username, but couldn't find anyone. So just it's somewhere in the slides, so just look it up. Pay attention. So welcome, everyone. Happy to see you. It's a good turnout. That's great. So we'll be talking about controlling Nodebots with Kinect gestures today. For those of you who were expecting like Terminator-like robots and Skynet and all that stuff, no, this is it. Sorry. So it's a little bit tiny. It's kind of cute still. So if you're interested, you can come and pet it later on. So let's get started with this. All right. So I'll talk a little bit about myself, why I built this library, the goals that I was trying to achieve with that. So what existed, what I had to build myself. I'll present a little bit about the library that I actually built in order to make it work. And I'll show you a quick demo afterwards. Hopefully, you won't fall asleep due to food coma. So I'll try to keep you awake. Hopefully, the demo part, will be the exciting part that will wake all of you up. So let's get started about me. So I'm a development manager. I manage a team of developers, software developers. I work for a company that's called Macadamian. We are based in the Ottawa region. We do a lot of cool stuff, different projects. We have all kind of various customers. We touch all kind of technologies, JavaScript, mobile programming, robots, and a lot of different things. We also build fun things like Twitter connected plans and stuff like that. So if you're interested, we're hiring. So I had to plug it so that they will actually pay for my trip over here. So, done. I took the train to come here. I had a little boo-boo. So my robot got a major beat up in the train on my way in. Thankfully, duct tape, best friend, my best friend, at least. So I think it's kind of fixed and it kind of holds together. Hopefully, it will actually last until for the duration of this whole presentation. But yeah, let's see what's going on later on. So why would I try to build a library to detect Kinect gestures? So there's a lot of different reasons. First of all, I've been playing with Nodebots for a while. Who here went to the Pearl's talk just around 11? Just out of curiosity. Okay, so a few of them. So it's kind of the sequel to her talk. I was actually very happy to see that. Super interesting, so we'll take it one step further. So I've been playing with Nodebots. So it's an Arduino board that I have here, and everything is controlled via NodeJs. I'll show you a little bit about the stack in a few minutes. So I've played with it for a while, a few years. I wanted to explore other things around Node.js. So there's a lot of different things that you can do with it. So I wanted to explore the possibilities of Node.js. I also wanted to build my own Node module so that I could be famous, publish that on GitHub, and then travel the world doing presentations. So I've made it to Toronto. Getting there. And I mean, let's face it. Controlling a robot with Kinect gestures could be kind of cool. So that was the idea behind this project. So my goal was I needed a way to use some sort of events to tell the robot to do something. I could have went with the way like just trying to detect a movement with the Kinect and try to mimic it with the robot. But I kind of needed a beginning and an end, so I wanted to do gestures, or I figured that gestures would be a good solution for that because you can actually do a movement and there would be a response. So it's just another way of interacting with some other hardware without using a keyboard, to give it commands, essentially. So naturally, gestures came out as a good way to do that. So yeah, like I said, just being able to swipe your hand and then having some response on some hardware was kind of my goal for this project. So I started just like everyone else that starts on a project. So I've looked up what's available as open source libraries. Because let's face it, all we do, us developers, is just connecting open source stuff together to make another project. So this is what I did. I started looking up. So what currently exists, I'm using the basic Nodebot Stack, essentially. So if you've did a little bit of programming of hardware, you've probably used those already. So NodeJs, everybody's familiar here with NodeJs, hopefully. I will not go into the details of what it is. But essentially, it lets you program JavaScript and run those JavaScript files on your laptop, on your computer, rather than in a browser. Socket.io. Who here is familiar with WebSockets? Oh, great. It's a good portion of you guys. Unfortunately, we don't see those enough in enterprise-level projects. At least I don't think we see it enough. But essentially what it is, for those who didn't raise their hand, so WebSocket establishes a tunnel between a server and a client. What does that mean? Essentially, it gives you a bidirectional communication between a server and the client. So if you're used to typical web programming, where you had the client that always has to ask the server and fetch data from the server, then with sockets, you have a way to do bidirectional communication. So the server can actually push data back to the client without the client actually asking for it. So it makes it really, really good to work with for robots programming. Because if you want to have something react on the screen when you press a button, for example, then you can press the button, send the information to the server, and server pushes back the information to your client. So the client doesn't have to fetch, and you won't wait for this polling to happen. Sorry about that. And JohnnyFive. JohnnyFive is a Node library. It is used to connect hardware on a Node server. Super cool library. I'll just take 1 minute if I can find my browser window again to show you the type of support that it has. So once again, if you were at Pearl's presentation, so Arduinos, Tessels, Arduinos, other Arduinos, particles, name it, just take a quick look. Raspberry Pis, just about anything you can think of is supported by this. So it gives you a set of common APIs that you can use with just about any type of hardware. I've used it with Arduinos in this case. I've worked with it with Particle or Spark. Works super well with that. Electric Imp. I've used it on Tessel as well. So it's really worth to explore this so that you have a common set of code, basically, or a common code base that you can reuse, and no matter what's the hardware that you have behind it. If I can just find my cursor, we'll get back to this. So this is what was existing. This is what I've been playing with for the last few years. And as I said, I kind of reached a limit where I was comfortable using those. Built a few projects on my own just for fun. So I wanted to take it one step further. So what else exists? Node OpenNI. So OpenNI is, once again, open source library that is there. And it enables you, or it's a set of DLLs, or whatever is the equivalent for Mac, so that you can actually connect your Kinect, and it will read the data from the Kinect and send it back to whatever you connect to it. Node OpenNI is a library, a Node module again, that actually makes the links so that you can use this library to fetch all the data that comes in from your Kinect. The problem with it is that it has essentially one event that sends you a bunch of data. So you have to check the number of parameters that you have, and then you kind of guess what's the data that comes in. Really, really not dev-friendly. Kind of works. Actually, it works really well. But it's super hard to work with it. And obviously, it doesn't have gesture detection. Well, not obviously. I was kind of hoping that it would have it, but it didn't. So what did I need? So my main goal was to be able to have gestures. So I needed to find a way to support gestures, obviously. I also wanted to have support for a full skeleton. So rather than having just a bunch of data that comes in, I wanted to be able to track a skeleton, a full person, with a series of points that I can put in space, and then use that data to detect gestures or to display data on the screen. So I had pretty much all I needed. I knew that I had to build this library that would give me the skeleton support and the gesture support. But how do you actually detect gestures? So that was my main, my first hurdle. When I started thinking about it, I was like, oh, how am I going to detect that I have a movement? And it kind of took me a while to figure out what it was. Okay, you'll see it, so it's kind of obvious. But when you're thinking about it, it's not that obvious for the first time. So the first thing that you need to check for is an initial condition. So you need to see if there's something that will start an event or start a gesture. Then you need to periodically check, is the condition still met? Is it still on the path of reaching this gesture? And then at the end, you have to check, is the final condition met? As I said, it's kind of obvious when it's stated there, but I had to think a little bit about it. So how did I build that? Well, first of all, I needed my skeleton, like I said. So I needed to build this piece of software that will return me a big skeleton. So I had a series of joints that I track, and that's my skeleton. So I have joints for my shoulders, my knees, my toes, knees, toes. Okay. Knees, feet, shoulders, head, stuff like that. So there's a few strategic points that we're tracking in time, and that's what we build the skeleton for. I also needed the position of the center of mass. Well, technically, it's not the center of mass, because it doesn't account for this. But it's kind of a point in the middle. COM was just an easier variable name. And I needed a base unit. So that was my biggest breakthrough. That's the part that I'm most proud of. So it's part of the framework now. So the first problem that I encountered was that if I move my hand like this in front of the Kinect, it kind of detects a movement that is 1,000 pixels wide. But if I go at the other end and I move my hand like this again, it only detects a movement that is about 100 pixels wide. So how do I deal with that? And how can I detect gestures with the fact that I can never have a specific measure? So I needed this base unit. And essentially all it is every movement is parts of this base unit. So in the x-axis, a base unit is from one to the other. Z-axis is the same thing. And for the y-axis, it's essentially from my feet to my hand up there. So once that I have this, now I know that or this base unit, now that I move my hand like this, it will return me a value in base units, so something like 0.3 base unit, rather than being a unit in pixel. All right. And there it is, Kinect gesture, available on NPM. So what it is, it's a gesture detection. It's a base class that you can expand on, and you can add some gestures to it. Tracks your skeleton for an initial condition. Once it detects this initial condition, it checks every 100 milliseconds to see if the condition is still met. So the example that I will show you is the right hand swiping left. Yeah, left. So the initial condition is, is my hand in front of my center of mass? If it is, yes, then the initial condition is set, and then we start tracking every 100 milliseconds to see if the hand is actually moving left. And if it ever goes right from the initial position, then it stops tracking, because the condition is not met anymore. And then we track to see if there's a final event. So what I'm tracking in this case, I swipe my hand, and if we reach 0.3 base unit, then we trigger the event, the gesture was detected. And it's a bunch of classes, so every gesture that you want to add, you just add in a file. You enter conditions for all those conditions, and it will automatically take care of the looping, the checking, and all that stuff. So let's look at some code. Right. Sorry for the color, they kind of flicker a little bit. All right. So if you go on GitHub, you'll be able to find all this code. I will share my slides after the presentation, so you can find all the information there. And you can find all this source code as well as the examples that I will be showing. All right. So essentially what I have here is one, this is my base class. So this is where all the magic happens. Not all of it, but parts of it. And I have the base gesture. And the base gesture is essentially responsible. I won't go through each line of it. But it's responsible for all that loop, all that checking, making sure that it periodically does the checks, stops checking if the event is not met, and so on. So this all happens in there. And let's take a look at right hand swipe left. All right, so this is the interesting part. So whenever you want to add a new gesture to your project, say you want to detect somebody jumping, you'll want to detect different things. In this case, we're looking at right hand swipe left, which is fairly easy. So what we do is that we extend the base class, which, like I said, it takes care of all the handling of the looping and so on and so on. So we extend on this, and then we just add initial condition met. So in this case, I'm looking at if the distance from the hand to the center of mass is bigger than 0.1 base unit. So as I mentioned, using base units here makes it a lot easier than having to try to track the number of pixels depending on the distance of the user from the Kinect. So base unit makes it a lot easier there. So I'm detecting is the hand in front of my center of mass. So essentially, if it's there, there you go. You have it. The initial condition is met. Then I have another condition or another method, and it simply returns true or false depending if the condition is still met. So you have access to the current skeleton. You also have access to the initial state, so the initial coordinates. So when I put my hand in front of my body, it takes the coordinates, stores it somewhere. So as it checks, it will keep that one in mind. So I can detect if the hand is actually moving left, or if it's moving right. If it's moving right, it'll just exit the loop. And then final condition. So in this case, I'm looking if the, actually you don't see it, all of it, but I'm looking if the movement was more than 0.2 base units. So if it moved a distance of 0.2 to the left, the final condition is met, and it triggers the event. As I demo this, I realized that 0.2 is a little bit sensitive, and I have the habit of just gesturing a lot when I talk. So if I demo it, you might see it go crazy a little bit, but that happens. So that's all there is to it, essentially. So if you're interested, go ahead, npm install. You can take a look at it. You have all the code there. But of course, that's not really interesting, right? So you have to take a look at an example. So once again, I'll go through some more code. I promise you, we'll get to the demo part, the exciting part, the part that will get you out of the comma in a few seconds. But just before, we'll look at the code. So I wanted to give you a quick idea of how to use it and how to just quickly run a node server with a socket I/O and to control the robot, so with the JohnnyFive installed. So if we start with this demo, so I'm calling my Kinect and I'm calling tracker, so I just require modules, just the way you would do with any other module. Tracker is my gesture detection library. You might have noticed that I've changed the name a few times. I guess that's what happens when you work on a project once every 6 months. But in this case, it's called tracker. Oops, sorry about that. OK. Then I declare a variable. I require express. Express is a node server. Hopefully, everybody's familiar with that. So just a basic web server, nothing fancy there. Well, it's a very interesting web server, but still. And then I require socket.io, and I just hook it up to the web server that is running. All right, so I have a few constants. Let's forget about those. And then I check for a file. I just send the file if somebody requests a file. Basic Express stuff. And in here, this is the interesting part. So my tracker has a few events, so it's event-based. Kind of makes sense for this type of thing. I have a skeleton changed event. So whenever there's a movement that is detected in front of the Kinect, it will just trigger the skeleton changed event. And it returns a skeleton object, which is an array of, or an object with a bunch of coordinates for a bunch of joints. So once the event is triggered, I will emit to using the socket. So that will send a message to the client that is connected to this. So it emits to the client. It triggers a skeleton event on the client, so in the browser. And it sends all the skeleton data. I've had some problems with it. If the actual node library goes really, really fast. And if I had to debounce it a little bit, just because if I was sending all the information, it kind of exploded at one point. So I debounced it, so I just send the information every 100 milliseconds. It's a completely arbitrary. Are
you debouncing to like a frames per second kind of target?
No, it was just a arbitrary value that I put there. It's probably related with the number of frames per second, or I could probably explore. Quite frankly, I didn't bother. I just added a timeout, and it works well. And that's it. So let's give it a try. Right, you will notice that I'm using N rather than Node. Last time I actually gave this conference, funny thing, I was at my hotel room the night before, and I was just playing with my computer, and I said, oh, well, look at that. Node 4.0 just came out, so let's upgrade. And then nothing worked anymore. So N kind of saved my life, so it just lets you run any version of Node. So rather than using the one that is currently installed or used with the Node command line. I don't know, I was just playing with it. I installed 10.33. No specific reason. Once again, it just kind of was following the tutorial, and that's the version that's suggested, so it works. All right, let's give this a try. All right, so I have a web page that is connected to it, to my server. So as you can see, it's actually served there. All right, it detects that I'm there, so let's try to calibrate it. And there it is. So you can see me moving. OK, so that's the exciting part. Come on. All right. OK, so now that I had this part, I was super excited, as you can tell. So now that I knew that the skeleton detection and everything was working, and as you've seen, the socket was working. So as soon as it detects the movement, it sends the information to the web page. The web page, which I forgot to show, only has this, essentially. So whenever you connect to the web server that has the socket server on, it will add a I/O method to your page so that you can use that. And then with that, you kind of have access to the events that were triggered by your server. So yeah, when it gets the skeleton, it just receives the skeleton object. I have this method which is draw joints. It's a bunch of math calculations, not super interesting, but essentially it just draws some divs, some lines, and it kind of rotates them with CSS. So that's what it does. So I was very excited with that, so I decided to try to track gestures, which was the case, the actual use case for this. So let's look at a little bit of code again. So I still have the same thing. So I have this tracker whenever the skeleton changes, trigger an event, and yada, yada, yada. But I added this part. So what I added here is that I registered a bunch of gestures, and it relies a lot on convention. So if I try to register a gesture which is called a right-hand swipe left, it will try to look in the gestures folder, try to find that file, registers it, and creates the events based on a naming convention. So it's gesture, colon, and the name of the gesture. So I register a bunch of events here. And when they occur, I just emit an event using my WebSocket again. So it's even simpler than the part that I showed earlier. And on my web page, now I've added a bunch of new events for this socket. So my socket detects that there's an event that is triggered. And what I do here is that I simply add some color to the joint that is detected, or to the hand that is detected, or where it detects a gesture. So let's try to give this demo a try. All right. Hopefully this will work. Demos never usually work, so I'm actually surprised that it does. But forgot the web page. Sorry about that. Let's try it again. Let's refresh this. All right. OK, so it detects me. Let's calibrate it. All right, so calibrated. Now, so I swipe my hand right. So as you can see, it changes to green. And should be red on the other side. Same thing with the left hand. So red and green. So there you go. So I had my gesture detection. Was almost there. So let's remember the main goal was to actually be able to control a robot with this. So now's the fun part. Not that the rest was not fun, but OK. All right, still have plenty of time. I realized that I was going really fast. Sorry about that. OK, so I started. So here is essentially the same code base as I was using for the gesture one. But I added the JohnnyFive part here. So JohnnyFive, just like pretty much everything in Node, is usually very simple. So it's a matter of requiring the module and then working with the API. The API is fairly simple. It uses an event-based. It's an event-based library. So I'll just show you how I used it here. So I require JohnnyFive, and I give it a name. Nothing surprising here. And I create a board. So the board can be, as I mentioned, just about anything. In this case, I'm using the default, so that's why the port is commented out. You can detect a board in various ways. I have a Bluetooth connector here, which I use at home, but it's not very reliable. So I try to give all my chances on my side for this presentation. So I'm using a USB cable. So an Arduino board, USB cable, you don't need anything. So it just works right out of the box. There's a little bit of magic or a few command lines that you'll need to add if you want to use it with a particle. You'll need to add all the API keys and such. So depending on the board, you'll probably need to write a little bit of code here to make sure that it works with whatever hardware that you have connected. But in this case, works right out of the box. I don't need to do anything here. Once you have a board that is connected, it'll have an event, ready event. So just like jQuery and checking if the document is ready, we're looking if the board is actually ready. And once it's ready, it means the port is actually open, the connection is working. And then I can start doing some code and perform things on it. If you want to use it with an Arduino, you have to, or actually with most boards, you need to start by putting some code on your board, of course. In the case of Arduino, it's the standard Fermata, so it's a protocol that is used. So rather than putting some code on the board, and the board will just loop through your code on and on, it listens for commands that you will send to it. So JohnnyFive does that, so it sends the commands to the board, but you need to install this standard Fermata on the board first. Once you have this, then you can create a bunch of things that you connect to your Arduino board. So in this case, I have two motors. So left motor, right motor. You just define new JohnnyFive motor. You figure out what pins are used for the motors. In my case, I'm using a motor shield. So by default, those are the pin numbers for the motors. I also connected a few LEDs, two LEDs, because what's hardware without LEDs? That's the fun part of it. And it's pretty useful for hello world operations type of thing. So I've connected two LEDs just for the fun. So once again, you just create a new LED, and you give it the pin number. And that's all you need. Just to test it, I blink the LEDs to see if it actually works and does something. I've added a little speaker as well, which I forgot to connect, so I'll just connect it right here. It's probably the most annoying sound that you've ever heard, but we'll still play it just for fun. And then I have a series of functions, so move robot, so I can move it forward, backward, so on and so on. So if I want to move the robot forward, I take my motors, I say direction forward, and I give it a speed as a parameter. Then I set a timeout, which is 1 second in my case, and I stop the motors, because if you don't stop them, well, it just won't stop, and it will fall off the table, and that will not help. And just to give you an example how to blink LEDs, so if you want to play with it, then start with a very simple hello world. Blink LEDs is such an example. So I'm just calling the LED. I store it in a variable, so I can use it there. And blink is a method for it. 500 is the number of milliseconds between the on and off. So it will just start blinking. So that's pretty much all there is to it. So as I said, JohnnyFive makes it really, really simple to actually interact with hardware. It makes it so that hardware is actually something that is possible for us software developers to actually interact with it. So you don't have to bother too much yourself about how everything works and how to connect everything and learning C++ low-level stuff to upload to your chip and yada, yada. So you can just use JavaScript. Makes it a lot simpler. All right, so back to my example. So I've added a few things to my gesture detection. So whenever it detects a gesture, right hand, it will move the robot either forward or backward. And the left hand will play music and things like that. All right. So this is my last demo, the most amazing one. OK, let's give it a try. Right? OK. So it worked. As I said, it's probably the most annoying sound. OK, so let's try to make it move now. It's trying to do something, right?
Yeah, the LED is turning on, the blue one.
So if I connect the motors, it'll actually help. All right, let's give it another try. So it works. All right, so just to conclude this, and I'll have some time to take on a few questions if you have any more afterwards. So I still have a few steps that I wanted to take it a few steps deeper. I want to return a coordinate system, so I haven't shown you how I draw the joints on the web page because it's just a mess. It's relying on actual pixels rather than relying on base units. So there's a lot of stuff that I could do to make it a lot more developer-friendly hit there. Add more information to the returned. I absolutely need to do that as well. I need to add some documentation as well. If you go on my GitHub page, you will notice that it kind of lacks documentation. And I want to add a few more gestures just for fun. So stuff like jumping, kick, or stuff like that that are a little bit more kid-friendly, maybe. I want to do this or to bring this at Makers Fair and stuff like that, just for fun and just to show kids that it's actually fun to interact with hardware and software. And that's it for me. Thank you very much.